We're in Scottsdale, Arizona. We just did the ground up for a residential install. Let's go walk around, see what it looks like at finished product. So this is our service for the house. Start out, we got a 400 amp service for a house. It's a little larger than normal. You have your two different panels. We got our main breaker here, which is derated for our size of our solar system, and that feeds the breakers in this panel. Then we have another 200 amp main breaker that's going to feed a sub panel, which in this case is right next to it. The second breaker feeds all these guys. This is a large house, so that's why we have two different panels and have so much power here. Once we're done, we send it to APS. They have to send a crew out here to put in their meter. They'll lock out our disconnect, and that's commissioning it. We'll be able to turn it on. This solar array, we got 34 340 watt hand wall panels, and we're using IQ7 inverters. They're micro inverters, so instead of a big inverter box here, there's small inverters underneath the panels. Every panel can produce as much as it's capable with the sun. This is our smart switch. We have so many panels on here, we have multiple strings of panels. They use the micro inverters, but this is where we actually bring them all together. As you can see, we have 3 different strings on here. We bring them together, and then this unit is what actually feeds into the panel. It's our combiner box. All of our roof solar comes to here before then going to what we saw on the other side and going into our electrical panel through the meter and disconnects. Enphase has a lot of good products that we like to use to match to your house. I mentioned how this is derated. Normally you have a 200 amp breaker, just like this breaker would be in this spot. The busing right here, which is what all the breakers attach to, is rated for 200 amps. To code, the input current you can have on that busing can only be 120%. Since our array is a bit bigger than that, we wanted more solar. We have a 60 amp breaker here. In order for us to put that in, we actually changed this breaker to 175 amps. So 60 amp breaker here for solar to handle our system. We need to put a 175 amp breaker in here to allow us to be within that 240 total amps going to the bus bar. 175, 60, we're at 235. So technically we could go 5 amps bigger if they ever wanted to increase it a little bit. So as you can see here, there's a few different types of breakers, even though they all say 20 amps and they're single poles. If you look here, the blue ones, these are what we call an arc fault breaker. To today's code, when you have a living area, like your bedrooms, your living rooms, they put these arc fault breakers in. It's just an added safety feature. If they sense an arc flash, they'll trip the breaker. You have over here, you have your standard breaker, and this is just for non-living areas. This is just the regular breaker we put in for everything else. Right here we got our fridge, laundry room, mini splits. Our 2 poles are more advanced. These blue ones are arc fault and GFCI combo breakers. GFCI you might be familiar with. The breakers, the outlets in your house that have a test and reset button, they're a GFCI outlet. It's a ground fault current interrupter. With these breakers, we don't put those outlets in. That function is handled at the circuit breaker. So if it gets wet, if you get an arc, it'll trip this. You can come out here, reset the breaker, instead of trying to find where that one outlet is that you have to put the reset button on. The green ones are arc fault only. And these, they don't have the GFI protection. They're just for the arc fault in case there's an arc flash, they'll trip in that feature. Your outlets inside your garage need to be GFI protected. We're labeled it with the GFI sticker right there, but instead of an outlet, this is actually protected at the breaker. So if a ground faults, you reset the breaker instead of having to find the outlet with all the buttons on it. So just like all the houses in here is LED throughout the house for our energy efficiency. So here we have our lighting control panels. This house, all of the lighting through the house is actually controlled through these light switches. They're all low voltage light switches that run here to control all the circuits that go out to the lighting. So these are central units that bigger houses like to use. So you can do all your 120 troubleshooting from here, and you have just low volt light controls throughout the rest of the house. They have their IT cabinet up here. All their Cat 5 wires, Cat 6 wires run to this, kind of like a data room. This house has a centralized vacuum system. You essentially just have to plug a hose in there. For that port you just saw, it's here. You just plug in your hose and it sucks everything over to here. This is to control our heaters that we saw on the porch, the back patio, as well as the misting system. Power comes into here and then it goes off into the house, and there's a few breakers in here. This is just our control panel. This is going to help the heaters that are going in the Ramada that they're building later.